Dear students, welcome to the lecture 1 of Security of Information Systems course. In this course, my aim is to give you an overview, a general idea about security of online systems, IT systems. This area is a profession of its alone. It cannot be fully understood. You cannot become an expert of this area with just a single course, with just a single lesson. So we will see many of the things with just overview to get an general idea. However, if you get such security job in future, you will know where to look, you will know where to study, so you will have a basic idea. But to become an expert, as I said, this is just a profession itself. Like you need to study 4 years of security systems, like you are studying software engineering. However, you will get an overview, a general idea. Okay, so lecture 1 is basic concepts in information security. I will be using Auden Joycing lectures. He is a professor in University of Oslo. I will be using his 2018 lectures. Okay, let's start.
Why study information security? Being an IT expert requires knowledge about IT security. Analogy: building architects must have knowledge about fire safety. Developing IT systems without considering security will lead to vulnerable IT systems. IT experts without security skills are part of the problem.
Okay, so what does this mean? This means that if you are going to be an IT expert, you have to have at least some sort of security uh, consciousness. You have to consider security at least when you are programming a software. Uh, this is extremely important. You have to have awareness of security and do your codings, do your tasks with considering the highest possible security.
Learn about IT security to become part of the solution. Security by design is a prerequisite for privacy by design, which is a legal requirement for processing personal data. Information security is a political issue, often seen as a cost, but saves costs in the long term. Often given low priority in IT industry and IT education.
This is so true. We always hear that very big e-commerce companies are getting uh, penetrated by hackers. Their information is getting stolen and such things because they only focus on selling products and making profit. They don't give the importance that IT security, the quality of the software deserve. And they may not lose anything if they don't get hacked or any problem occurs, but if that happens, they lose much more than they would spend to hire IT security expert or hire uh, uh, expert software engineers to have secure systems.
Certifications for as professionals.
IS is IT security, information security.
Many different types of certifications available. Vendor neutral or vendor specific. From nonprofit organizations or commercial for-profit organizations. Certification gives assurance of knowledge and skills needed in job functions. Gives credibility for consultants applying for jobs, for promotion. Sometimes required. U.S. government IT security jobs.
Actually, this is same for many of the countries. In Turkey, they would require to have certifications for almost everything, for every job.
Knowledge domains reflect current topics in IT security. Generally kept up to date. ISACA certifications. Information Systems Audit and Control Association. ISACA provides certification for IT professionals. CISM. Certified Information Security Manager. CISA. Certified Information System Auditor. CGIT. Certified in the Governance of Enterprise IT. CRSIC. Certified in Risk and Information Systems Control.
So you see, ISACA provides certification for many IT professions. You can get any of these as certified, and if you get certified, you could have found lots of awesomely paying jobs in United States, in Turkey. Then maybe companies looking for such certified people, certified IT professionals, and it is about these are about this.
CISM is the most popular ISACA security certification. IT auditors and consultants commonly have ISACA certifications. ISACA promotes IT governance framework COBIT.
So what is COVID?
Control objectives for information and related technologies. CISM, Certified Information Security Manager. Focuses on 4 domains of IS management. 1. Information security governance. 2. Information risk management. 3. Information security program development and management. 4. Information security incident management. Official Prep Manual published by ISACA.
So let's it opened ASN. Okay, let's ignore it. Okay, there is also an exam of CISM.
Exams normally twice per year worldwide. 2018 exam information to give you an idea.
Okay, so this was the information of 2018. You see there is a deadline to register, the registration address, the fee is approximately $500 and such. So if you get that exam, you get certified, and per year I think they are charging $100 for maintenance and such.
ISC 2 certifications. International Information Systems Security Certification Consortium. ISC 2 provides certification for information security professionals. CISSP. Certified Information Systems Security Professional. ISSAP. Information Systems Security Architecture Professional. ISSMP. Information Systems Security Management Professional. ISSEP. Information Systems Security Engineering Professional. CAP. Certification and Accreditation Professional. SSCP. Systems Security Certified Practitioner. CSSLP. Certified Secure Software Lifecycle Professional. CISSP is the most common IT security certification. Most IT security consultants are CISSP.
So let's say you want to become an IT security consultant, you get such a certificate and you prove that you know what is IT security, how experienced you are. It is same as the job offers that require certifications.
CISSP exam. Certified Information System Security Professional. Many different books to prepare for CISSP exam. e.g. textbook used for INF 3510 course CISSP all-in-one exam guide 7th edition, 2016 author, Sean Harris and Fernando Mamie.
So the professor prepared these lecture slides, used this book, and you may get such book, you may purchase and develop your skills, become an expert of IT security. As you can see, he also says that most of the material presented in this course is taken from CISSP CVG. Okay, there are 8 domains. One second.
CISSP CBK, Common Body of Knowledge. 8 domains. 1. Security and Risk Management, Security, Risk, Compliance, Law, Regulations, and Business Continuity. 2. Asset Security, Protecting Security of Assets. 3. Security Engineering, Engineering and Management of Security. 4. Communication and Network Security, Designing and Protecting Network Security. 5. Identity and Access Management, Controlling Access and Managing Identity. 6. Security Assessment and Testing, Designing, Performing, and Analyzing Security Testing. 7. Security operations, foundational concepts, investigations, incident management, and disaster recovery. 8. Software development security, understanding, applying, and enforcing software security.
Okay, there are some security surveys if you want to check, and their links are provided. And there are some security advisories if you want to check them. There was also an academic forum on security. Probably it is held every year. You see, the professor prepared these slides, were also a speaker in that security seminar. Okay, it was organized by Security Lab. And let's start with Information Security Basic Concepts, Lecture 1.
What is security in general? Security is about protecting assets from damage or harm. Focuses on all types of assets. Example: your body, possessions, the environment, the nation. Security and related concepts. National security, political stability, safety, health, environmental security, clean environment, information security, etc.
Okay. So what's information security?
What is information security? Information security focuses on protecting assets from damage or harm.
But which asset? Which assets? Information assets. So the main difference of information security is securing information assets rather than physical assets or other type of assets.
What are the assets to be protected? Example: data files, software, IT equipment and infrastructure. Covers both intentional and accidental events. Threat agents can be people or acts of nature. People can cause harm by accident or by intent. Information security defined. The preservation of confidentiality, integrity and availability of information. In addition, other properties such as authenticity, accountability, non-repudiation and reliability can also be involved. ISO 27000 Information Security Management Systems, Overview and Vocabulary. Scope of information security is management has as goal to avoid damage and to control risk of damage to information assets.
Is information security.
Is management focuses on understanding threats and vulnerabilities, managing threats by reducing vulnerabilities or threat exposures, detection of attacks and recovery from attacks, investigate and collect evidence about incidents, forensics.
So if we talk about this, you need to understand threats and vulnerabilities to take precautions. You manage them and reduce them. Detection of attacks and recovery from attacks is also very important. You need to quickly understand that you are under attack and you need to have proper backups so that attack cannot harm you permanently. Investigate and collect evidence about incidents is very important because you may would likely to take legal action against the attackers, or you can find why attack happened, how it happened, and you fix the vulnerabilities, you prevent the future attacks and such.
The need for information security. Why not simply solve all security problems once for all? Reasons why that's impossible. Rapid innovation constantly generates new technology with new vulnerabilities. More activities go online. Crime follows the money. Information security as a second thought when developing IT. New and changing threats. More effective and efficient attack technique and tools are being developed. Reasons why that's impossible. Rapid innovation constantly generates new technology with new vulnerabilities. More activities go online. Crime follows the money. Information security as a second thought when developing IT. New and changing threats. More effective and efficient attack technique and tools are being developed.
Okay, I have repeated the reasons because they are really important. As you know, uh, many of our devices get updates frequently, and these software updates means that there can be always human mistakes that can lead to information security problems. More activities go online. This is so true because something has to be accessible to be vulnerable. Let's say your home computer is not connected to the internet, that means that it can be only infected by physical means, but not from internet, not from anyone. Crime follows the money. This is so true. In recent years, uh, chiropter, there are viruses that encrypts your uh, uh, data and request money from you. They are called as ransomware, and this is increasing every year. This is increasing as by the time goes, and they are requesting bitcoins from you since bitcoins are not tractable. So crime follows the money. This is true. Ransomware is just one of the example. Yes, security is not taken seriously when developing IT. This is true. New and changing threats, as always, and more effective and efficient attack techniques are becoming developed, and not also they are being developed. They are also becoming more available to the more people, and so more people are able to do such effective attacks and cause harm, damage.
Conclusion. Information security doesn't have a final goal. It's a continuing process.
This is so true. So, IT security is one of the jobs of future. If you become an expert of IT security, if you become IT security expert, information security expert, then you will likely to get paid very well. Okay, there is a chart like this. Let's see if the website is still working. Okay.
Summary. The survival time is calculated as the average time between reports for an average target IP address. If you are assuming that most of these reports are generated by worms that attempt to propagate, an unpatched system would be infected by such a probe. The average time between probes will vary widely from network to network. Some of our submitters subscribe to ISPs which block ports commonly used by worms. As a result, these submitters report a much longer survival time. On the other hand, university networks and users of high-speed internet services are frequently targeted with additional scans from malware like bots. If you are connected to such a network, your survival time will be much smaller. The main issue here is of course that the time to download critical patches will exceed this survival time. In order to help users set up new systems, refer to our guide, Windows Vista. First steps, a follow-on to our guide, Windows XP, surviving the first day.
Okay, so this is the survival time. You can get more information from this website. Okay. Also, the malware trend is very obvious. Let's check the latest one. Okay, so you can see the malware trends by year, and it is growing really fast with a steady increase each year. In future, probably there will be more malwares. You see, there are also new malwares every month. Data. You can get more information on this website.
Security control categories.
Information security. Okay, physical controls.
Physical controls, facility protection, security guards, locks, monitoring, environmental controls, intrusion detection.
So these are the physically controlled things. Technical controls.
Technical controls, logical access control, cryptographic controls, security devices, user authentication, intrusion detection, forensics.
And software side controls.
Administrative controls, policies and standards, procedures and practice, personnel screening, awareness training, secure system dev. Incident response.
Okay. So there are three legs of information security. You have to physically control the environment. Let's say if your server is easily accessible by physically, they can insert any kind of unwanted software to your server. You have to physically uh, control safety of your server. Technical control, not everyone should be able to access to your server. And there is also administrative control, who is able to do administrative tasks and such. Okay.
Security control functional types. Preventive controls. Prevent attempts to exploit vulnerabilities. Example: encryption of files.
So let's say you have forgotten, or uh, you have left an exploit in your system that leaded attacker to intrude your system. However, you had a preventive control, which was encryption of your files. So the attacker only obtained your encrypted files, and uh, the attacker wasn't able to see what was the content of your files. This is preventive control.
Detective controls. Warn of attempts to exploit vulnerabilities. Example, intrusion detection systems IDS.
IDS. So in this case, you are running detective controls. If someone tries to hack into your system, you get a warning. This may be like, let's say, normally a client may be doing 100 requests per minute at max. And if there is a client doing 1,000, 10,000 attempts, you may get warned, or similar things can be detective control. You may put some traps to understand if someone is a regular client or he is an attacker.
Corrective controls. Correct errors or irregularities that have been detected. Example, restoring all applications from the last known good image to bring a corrupted system back online. Use a combination of controls to help ensure that the organizational processes, people, and technology operate within prescribed bounds. Controls by information states. Information security involves protecting information assets from harm or damage. Information is considered in one of three possible states. During storage, information storage containers, electronic, physical, human. During transmission, physical or electronic. During processing, use, physical or electronic. Security controls for all information states are needed.
So you have to have security when keeping the data, when transmitting the data, transferring the data, and when using the data. All three cases.
Security services and properties. A security service provides a high-level security property. The traditional definition of information security is to preserve the three CIA properties for data and services.
Okay, so what is CIA properties? These three are.
Confidentiality, integrity, availability.
Okay.
CIA are the three main security properties. Services, data privacy as an additional property which assumes CIA.
Okay. To have data privacy, you have to have CIA, which is confidentiality, integrity, and availability.
Security services and controls. Security services, aka goals or properties, implementation independent, supported by specific controls. Security controls, aka mechanisms, practical mechanisms, actions, tools or procedures that are used to provide security services. Security services, e.g. confidentiality, integrity, availability.
Support security controls.
E.g. encryption, firewalls, awareness.
So there are three services and there are three controls. And as an example, there can be more, of course. Okay, let's see them.
Confidentiality. The property that information is not made available or disclosed to unauthorized individuals, entities, or processes. ISO 27000.
So this is the definition of confidentiality in ISO 27000.
Can be divided into secrecy, protecting business data, privacy, protecting personal data, anonymity, hide who is engaging in what actions. Main threat, information theft, unintentional disclosure controls, encryption, access control, perimeter defense as general controls, also include secure systems development, incident response.
Okay, let's hear again.
Main threat, information theft, unintentional disclosure. Controls, encryption, access control, perimeter defense. As general controls, also include secure systems development, incident response,
Okay, integrity. Okay, integrity, data integrity.
data integrity, the property that data has not been altered or destroyed in an unauthorized manner. By .800, security architecture for OSI.
Okay, so this is the definition of data integrity according to X800 security architecture for OSI. Okay, so let's see this system integrity definition.
System integrity, the property of accuracy and completeness. Can include the accountability of actions. Threats, data and system corruption, loss of accountability. Controls, hashing, cryptographic integrity check and encryption, authentication, access control and logging, software digital signing, configuration management and change control, system integrity.
So these are the controlling ways of integrity. We will have an idea about them in future, more idea.
As general controls, also include secure system development, incident response,
Okay, availability.
availability,
So let's see the definition.
the property of being accessible and usable upon demand by an authorized entity.
Okay, main threat.
Main threat. Denial of service, DOS, the prevention of authorized access to resources or the delaying of time-critical operations.
It is very famous DDoS attack. So what is DDoS attack? DDoS attack means distributed DOS attack. It is one of the most famous attacking way to exhaust all of the available resources of a system so that the normal regular users cannot access that system.
Controls. Redundancy of resources, load balancing, software and data backups. As general controls, also include secure system development and incident response source, www.uio.no/studier/emner/matnat/ifi/inf3510/v18.
Okay, data privacy.
To protect specific aspects of information that may be related to natural persons' personal information. Prevent unauthorized collection and storage of personal information. Prevent unauthorized use of collected personal information. Make sure your personal information is correct. Ensure transparency and access for data subjects. Provide adequate information security (CIA) around personal information. Define clear responsibilities around personal information.
So GDPR is the regulation of Europe.
GDPR becomes EU law on the 25th of May 2018, 10101 data privacy to protect specific aspects of information that may be related to natural persons' personal information. General Data Protection Regulation.
Okay.
Authenticity Security Service. The CIA properties are quite general security services. Other security services are often mentioned. Authentication is very important, with various types.
Okay.
User authentication. The process of verifying a claimed identity of a legal user when accessing a system or an application.
So remember these pictures, they will be used in the following slides.
Organization authentication. The process of verifying a claimed identity of a legal organization in an online interaction session. System authentication, peer entity authentication, the corroboration, verification, that a peer entity system in an association connection session is the one claimed by .800.
Okay.
Data origin authentication, message authentication, the corroboration, verification, that the source of data received is as claimed.
Okay.
Taxonomy of authentication.
Authentication, entity authentication, user authentication. So to authenticate a user, what do we use?
Passwords, tokens, OTP, biometrics, PKI.
Okay, to authenticate an organization, what do we use?
Crypto protocols, e.g. TLS, PKI.
To authenticate a system, what do we use?
Crypto protocols, e.g. IPSIC, PKI.
Okay, to authenticate the data, what do we use?
MAC, DIG-SIG and PKI. User identification and authentication. Identification. Who you claim to be, method, user name, biometrics. User authentication. Prove that you are the one you claim to be.
Okay, we use our email or username to log in the websites usually. That is identification, and then we provide our password to prove that we are that user.
Main threat. Unauthorized access.
So main threat of user identification is, or user authentication is, unauthorized access.
Controls, passwords, personal cryptographic tokens, OTP generators, etc. Biometrics, ID cards, cryptographic security authentication protocols.
So these are used to control user authentication, passwords, cryptographic tokens, biometrics, and such protocols. Okay. And let's see the organization system authentication.
Organization system authentication. Goal: establish the correct identity of organizations, remote hosts. Main threat: network intrusion, masquerading attacks, replay attacks, DDoS attacks.
Okay, controls.
Controls: cryptographic authentication protocols based on hashing and encryption algorithms. Examples: TLS, VPN, IPsec.
So you may be wondering what are these? We don't have time to show all of them, but if you are wondering what are they, just you select these from the slide and search network intrusion. You will see what they mean from various resources.
A network intrusion refers to any unauthorized activity on a digital network. Network intrusions often involve stealing valuable network resources and almost always jeopardize the security of networks and/or their data.
You can get more information from the below link provided by the Google.
A masquerade attack is an attack that uses a fake identity, such as a network identity, to gain unauthorized access to personal computer information through legitimate access identification.
Okay. Okay, replay attack. Let's look from the Wikipedia.
A replay attack, also known as playback attack, is a form of network attack in which a valid data transmission is maliciously or fraudulently repeated or delayed. This is carried out either by the originator or by an adversary who intercepts the data and retransmits it, possibly as part of a masquerade attack by IP packet substitution. This is one of the lower-tier versions of a man-in-the-middle attack. Another way of describing such an attack is an attack on a security protocol using replay of messages from a different context into the intended, or original and expected, context, thereby fooling the honest participants into thinking they have successfully completed the protocol run. 1.
As you can see, there are many more information. You can look at them, and maybe all of you have heard this DDoS attacks. It is the most famous and most lamest one.
In computing, a denial of service attack, DOS attack, is a cyber attack in which the perpetrator seeks to make a machine or network resource unavailable to its intended users by temporarily or indefinitely disrupting services of a host connected to the Internet. Denial of service is typically accomplished by flooding the targeted machine or resource with superfluous requests in an attempt to overload systems and prevent some or all legitimate requests from being fulfilled. 1.
So in a DDoS attack, there is no security flaw actually. It is all about the massive number of incoming requests. Let's say you have a web server which can hold up to 1000 live visitors, and you regularly never exceed 1000 visitors at a time, so you don't need a stronger server. However, someone attacks you and sends your server 1 million fake visitors, and your real visitors becomes inaccessible to your server because your server is overloaded. A DDoS attack cannot be prevented without having extremely expensive resource bandwidth or resource management. It is the lamest and also one of the most critical threats to the web servers.
In a distributed denial of service attack, DDoS attack, the incoming traffic flooding the victim originates from many different sources. This effectively makes it impossible to stop the attack simply by blocking a single source.
So a DDoS attack can take anything down as long as they have enough number of zombie uh, uh, devices to operate the attack. You can see it is a pretty long page with lots of information. Okay, so what controls do we have?
Controls. Cryptographic authentication protocols based on hashing and encryption algorithms. Examples: TLS, VPN, IPsec.
So if you hide your server's real identity behind a VPN or such things, they may not carry a DDoS attack on you because they wouldn't be able to find your server's real IP address. For example, a free DDoS protection system, um, Cloudflare, does this for you. It hides your uh, server's IP behind some public IPs, and Cloudflare is huge, so basically taking down their servers is almost impossible for small and medium organizations. So if you are a small company that you want DDoS protection or some other protections, you may use uh, Cloudflare's free service or paid service. This is the perhaps the best option you can have at the moment.
Data origin authentication, message authentication. Goal. Recipient of a message, i.e. data, can verify the correctness of claimed sender identity, but third party may not be able to verify it. Main threats. False transactions, false messages and data.
Okay, this may happen, for example, in emails. Anyone can send you an email with faking its identity. So there are controls to control whether the originating email is truly that identity or not. This is very important one, data origin authentication.
Controls. Encryption with shared secret key. MAC message authentication code, security protocols. Digital signature with private key. Electronic signature, i.e. any digital evidence.
Okay.
Non-repudiation, strong form of data authentication. Goal. Making sending and receiving messages undeniable through unforgeable evidence. Non-repudiation of origin. Proof that data was sent. Non-repudiation of delivery. Proof that data was received. NB. Imprecise interpretation. Has a message been received and read just because it has been delivered to your mailbox?
Okay, main threats.
Main threats. Sender falsely denying having sent message, recipient falsely denying having received message. Control. Digital signature. Cryptographic evidence that can be confirmed by a third party. Data origin authentication and non-repudiation are similar. Data origin authentication only provides proof to recipient party. Non-repudiation also provides proof to third parties.
Okay, so this is the difference.
Accountability can be considered as a part of system integrity. Goal. Trace action to a specific user and hold them responsible. Audit information must be selectively kept and protected so that actions affecting security can be traced to the responsible party, TCSEC Orange Book.
For example, logging your IP address, the port you have connected, and the timestamp is used to trace. Okay.
Main threats: inability to identify source of incident, inability to make attacker responsible. Controls: identify and authenticate users, log all system events, audit electronic signature, non-repudiation based on digital signature, forensics. Authorization is to specify access and usage permissions for entities, roles or processes. Authorization policy normally defined by humans, issued by an authority within the domain organization. Authorities authorize, systems don't. Authority can be delegated. Management right pointing arrow size. Admin, implemented in IT systems as configuration policy.
Okay, so management is system administration implemented in IT systems as configuration policy. So authorities authorize, systems don't. That is the difference.
Identity and access management, IAM, phases.
So there are phases: configuration phase, registration of identity, provisioning of credentials, authorization of access, operation base, self-identification, authentication, access control, termination phase, deregistration, deactivate credentials, revoke authorization. Okay, simple.
Confusion about authorization. The term, authorization, is often wrongly used in the sense of access control. E.g. misleading figure on p.725 in Harris 7th ed. Common in textbooks and technical specifications, RFC 2196, Cisco AAA Server Authentication, Authorization and Accounting.
For example, let's open RFC 2196. This is a handbook, site security handbook. Okay, so it has many pages probably. Let's open the authorization. Okay, there is authorization.
Authorization refers to the process of granting privileges to processes and, ultimately, users. This differs from authentication in that authentication is the process used to identify a user. Once identified reliably, the privileges, rights, property, and permissible actions of the user are determined by authorization. Wrong usage of authorization leads to absurd scenario. 1. You get somebody's password and uses it to access account. 2. Login screen gives warning. Only authorized users may access this system. 3. You get caught and taken to the police. 4. You argue. Textbooks in security state that a system authorizes the user when typing the right password. Hence I was authorized because I typed the right password. 5. Case dismissed. You go free.
So you see, authorization doesn't mean of access control. Okay, it is being used in a correct sense. Authorization is actually this.
Authorization is to specify access and usage permissions for entities, roles or processes. Authorization policy normally defined by humans, issued by an authority within the domain organization. Authorities authorize, systems don't.
So in this case, system lets you get the access control, but the authorization is not. Because authorization only authorizes that user, that owner of that password, not the one who obtained that password. And this is somewhat related to terms. Okay, just get an idea.
Identity and access management concepts.
Okay, so user first register the identity provider system owner. The identity provider system owner does provisioning, and then if registration is successful, it provides authorization. It gets controlled from PAP policy administration point. If it is accepted, passes policy, it forwards to policy decision point, and then the decision is made. And if policy enforcement also verifies that the user can access system resources. This is the case of registration. If a user is already registered, the user log on with ID plus credentials. It can be password or such other things. User authentication function runs, and if authentication is successful, user requests resource and access type, then it goes to policy enforcement point, and if user has access to that data, accesses to that data. Okay, so this is the end of today. As I said, information security, security of IT systems is alone a profession. It can be an entire career. It can be an entire university education area like software engineering. It is impossible to cover the aspects with details in this course. However, you will get general idea about security, security mechanisms, controls, threats, and such things. Just look to the Google, and to get detailed information, look for the YouTube videos to get more detailed information about the things that you don't understand or you wonder. Uh, I will try to give you the general idea of most important ones, so you may search them, you may focus on them. Hopefully see you in the next week. We will have a GitHub repository, and all the resources will be posted on there. Just type GitHub Furkan Gözükara and open my GitHub page. Click repositories, and you will see the R course repository, which is this one. I will also share on LMS system of the school, so make sure that you uh, follow the LMS system of school. I will also send SMS messages. Okay, stay safe, be cautious of COVID-19. See you hopefully.